Hi there, I am Alex. Are you unhappy with the solution that you have when measuring used cells for your 18650 battery banks projects? Here's how we measure 16 cells at the same time with one mouse click.
Hey guys, here's a quick demo of the custom charging solution that we implemented for testing 18650 cell type. This is how it looks so far. We assembled all the parts, we got it working properly. It has a small display which cycle through the cells and display their values. Under each cell we have a temperature sensor which touches directly the cell. Not much to be seen on the board, but I will show you how it actually works in the software. For the software part, this is how it looks. You have all the cells displayed on this window here. You have the calculator section. This is going to pull data from the database in order to help you calculate the cell banks. Inside the settings, you have the option right now to scan for available cell doctors. My IP range is... You can also manually insert the IP address if you know it from the charger. For me, it found this, and I'm going to create a new project. Once you have the charger added to this drop down, you can connect to it. Once it establishes connection, you can now see the voltage and the capacity which was stored on the charger itself. You can control cells individually, so if you want to start charging, you can do on one cell at a time. You can measure capacity. The measuring capacity mode is going to check the voltage of the cell, compare it to the max charging voltage that you set in here, and if the cell voltage is smaller, then the max charge is going to charge the cell first, then measure the ESR and start discharging in order to measure capacity. You can also set manually discharge if you want to start measuring the capacity right away. You get the ESR as well, and here you can see the discharge rate and the voltage. Alright, so like I said, you can control cells individually, or you can perform operation on all the cells at the same time. I want actually to discharge them so I can get some data inside the capacity to show you how the calculator works. When it's starting, discharging is going through the ESR measurement. That adds a delay into actually starting discharging this. Once that's completed, you can see it starts counting on the capacity. Depending on the amount of amps which are being drawn from the cells and the time which the cell was discharging. So now I can create a new batch. When you have the project open and you click on the new batch, it's going to create a unique ID from the first 3 letters of the project. The second thing is the charger ID. I will show you in a second inside the database the charger ID. And then the last part is the cell number. So once you created the batch, you can write it to the database. We'll confirm that the cells were written. Now I can go ahead and use the free software for the database browser in SQLite. You can see you have the cell save settings. Because this is a new database, there was no settings saved. But now if we refresh, you get the settings which got saved. So next time you open the software, it will get the data from the database, the last used data. You have the cells added in here, the ESR, the capacity. If you don't change the unique IDs, you can keep writing to the database. That will update the data in here. And if you click on new batch, let's say you change the cells, you performed a new test, and you have a new batch, unique IDs are being generated, and you can now write to the database again. And now we have 32 cells which can be loaded inside the calculator. Right here you can specify the minimum capacity and maximum capacity for the batch that you want to create. Here you specify the number of cells in series and in parallel for your battery pack, and that will go through the database and try to calculate the best cells to be used together to have a low divergence, and it will show you the unique IDs of those cells which you should combine together. Once you soldered all the cells and you want to get them to mark them as unavailable in the database so you don't load them again for future banks, you mark the cells as used, and inside the database I'm not deleting them at the moment. They are marked as unavailable. In the future we might implement some cleanup tools to delete the used cells and stuff like this, but I figure you might want to keep them for now to see the total number of cells that you tested in the past and stuff like this. You also have the option to enable the cells or disable them. This will prevent the control all to be executed on the disabled cells, and also when you are going to write to the database, is going to skip the cells which are not enabled. This will conclude the demo of the Cell Doctor. I hope you enjoy it, and please keep watching the video presentation in order to find out what other benefits you can get by using this software.
Let me ask you something. Do you find yourself spending a lot of time recycling used battery cells? If you are doing 20 to 50 cells, then you will be spending almost a week with the regular 4-cell charger to measure capacity and insert all the data in a spreadsheet by hand. Being a programmer for more than 6 years now made me always look for efficient solutions to perform a task. I have looked around on how other people check the used cells, and I realized that if I were to perform cell testing on over 100 cells, it will take a few weeks to accomplish this using chargers and testers existing on the market. While this may be alright for some DIY enthusiasts which work on such project in their spare time, for others, like myself including, is a buzzkiller having to wait for so long and perform tedious tasks to match the cells afterwards. So how do you get around these problems? Is there any system or hack that will give you an advantage when performing these tasks? This actually called for a smart solution to be implemented to solve all these issues. While I am familiar with the hardware part as well, to make this project even better, I teamed up with Michael, which is a great friend of mine that is designing hardware as a daily job. We started working on a charger which will allow grinding through cells at a much faster rate, making it possible to test hundreds of cells in a really short period of time. After more than 5 hardware iterations and 6 weeks of programming, both the hardware and the desktop interface, we present our mass cell charger called the Cell Doctor. This device is capable of measuring the used cells with one click of a button from a desktop user interface. As I mentioned in the beginning, my name is Alex, and I am a professional software developer and content creator. In my newest project, I am building a power wall similar to the one from Tesla. I have started by researching on what others did and talked with people which successfully built their own high-capacity power walls so I can get myself a good starting point. I have learned that the majority of the battery banks are made by using 18650 cell type, which are also used in the original Tesla Powerwall. I have managed to find a great source of used cells, and the next step was to measure their capacity. That's when I have actually started working on my own charger and capacity measuring device to speed up the process. Here is how the Cell Doctor works. It connects to your wireless router and automatically gets an IP address. Desktop software controls the chargers and display all the required information. The Measure Capacity mode runs a charge-discharge cycle and measure the total capacity available for each cell. The software supports controlling multiple chargers from the same user interface. You just choose the charger, click the Connect button, and run any operation you want. You can create projects inside the software, and it will store the cell capacity information in a local database. There's a bank calculator functionality inside the software which is pulling data straight from the database and performs thousands of permutations per second to give you the best results for connecting your cells in banks. The software is really easy to use, and we have created video tutorials to show you the best workflow for using the Cell Doctor. While we were working on the prototype, I have posted on 2 Facebook groups where people are building all sorts of projects from power walls to electric vehicles, and asked them about their opinion on the features that we planned on implementing for this charger. We've got a lot of positive feedback and features suggested, but a major concern was the price at such device and software is going to be sold at. It's true that the features are saving more than 70% of the time which it takes to filter these cells, and to insert the info in a centralized database manually. But many people which are doing this kind of DIY projects will probably not afford paying a couple $100 for this solution, even if it saves them hours of boring work. Normally, the software alone would cost at least $100, and the hardware another $150, considering that a regular 4 cells charger costs $40. A total of $250 is not a bad investment if you consider the fact that it will make you the money back in just a few days of running the smart charger. But I know times are tough and you probably already invested in other equipment. So for the first batch of 250 Cell Doctors, we will offer the special price of just $97. That's more than $150 discount from what we could have charged and still call it a fair price. The best part is that you are going to receive free software updates if you purchase from this page today. After the first batch, we will probably reconsider the price for hardware and software. But if you buy today, you will get into our first clients list and you will receive unlimited software updates at no extra cost to you. So click the Order Now button below, and your Cell Doctor will be on the way to whichever place on Earth you live.